Hello students. From the previous sessions we have studied about RFLP, and from that we could understand that this is a tedious process because it requires a lot much steps like southern blotting, blocking of the paper, pre-hybridization, then hybridization, etc. So this RFLP altogether it is a tedious process. So a modification of it is present. Now I'm going to discuss about TRFLP. TRFLP means terminal restriction fragment length polymorphism. About the principle behind TRFLP, first of all we need to isolate DNA from organisms, and this is DNA from a particular organism, and that DNA need to be amplified with fluorescently labeled probes. So this is the amplified product. This is the normal reaction occurs in PCR. This is the template DNA. These are template DNAs. And here at the specific regions, these fluorescently labeled primers binds. This may be the forward and this may be the reverse one. So normally at 5' end of the primer, it may be linked with the fluorochromes. So 3' end normally extends during elongation process. Likewise in the reverse primer, this 5' end may be linked with the fluorochrome, and 3' may be extend during elongation process. So finally you will get products like this. But normally there is no need to use both of the forward and reverse primers as labeled. Here in this picture we have used only one primer, maybe forward or reverse one, may be linked with the fluorescence. So see this here at the 5' end, fluorescence over here. PCR amplified product, then you have to digest this PCR amplified product with the restriction enzymes. After digestion, you will get so many fragments like this: A, B, C, D, E, F, etc. Here, A, B, C are fluorescently labeled fragments, but D, E, F are not. Sample will be loaded onto a capillary gel electrophoresis. After restriction digestion, you have to load the sample onto a capillary gel. After restriction digestion, you have to carry out no, after gel after digestion with the restriction enzymes, you have to load the sample on a capillary gel. Then you have to carry out the gel electrophoresis. Then you will get a pattern like this. I think the larger fragment may be A, so that will come at top. B fragment will come next. Then I think next large may be F, so that may be come down to B. Next is C, then E, then D. Okay, but here A, B and C, A, B and C, they only contribute to the results because they only having fluorescence. D, E and F doesn't contribute to the result because it doesn't have any fluorescence. This is the schematic result. This is the capillary after electrophoresis. This may be read by a sequencer. If the sequencer read from the top to bottom, then the first fluorescent fragment comes is A. Then thereafter it is B. Okay, A. It's shown as a peak over here in the result. Next B, then F doesn't contribute to the result, then C, then E and D, it doesn't contribute to the result as well. So this pattern is peculiar or unique to a particular organism. Different organisms, this pattern may be different. That's why it became a molecular marker. Okay.